This is super exciting. The concept that the design goes through the user process. Anyone can have a suggestion. We'll design something, and somebody we've never heard of will say, this feature would be so much better if you just added this one. I'm like, that's a great idea, right? And then you're working for the next 2 weeks, right? to get this thing working. But again, patch review, testing, beta testing all happens, release all happens. The quality of getting beaten up on your patch and the quality of the release is because you have such an efficient system. Okay? And if you think about the IT infrastructure, the software that we use in IT infrastructure today, it is almost always using this. Okay? I mean, years ago they used to buy compilers, right? You used to buy a compiler, you'd buy an editor, you'd buy middleware, you'd buy all that stuff. Nobody buys that stuff anymore because this process is just so unbelievably efficient that commercial companies just cannot compete with this efficiency. Okay. Questions? No?
How do you release those patches from your review to the patch release?
Okay.
How do you release all your patches from the proposed features and you fix it? How do you release it from the internet to all the end?
Right. So what basically happens I'll just go through the calendar.
Yeah.
So starting in July, we will open up the Git repository, like GitHub or GitLab. But a local copy. We'll open up the Git repository. There are 22 people in the community who can apply patches to that repository. Okay, those are highly trusted people. And from July all the way until April, we will apply patches that come in from whatever source. They can come from Hong Kong, they can come from China, they can come from Russia, anywhere in the world. Somebody wants to add something to Postgres. They may work for Microsoft, they may be unemployed, they may work for a small company, a large company, doesn't matter. They go through the process. Do we want the feature? Post the patch, get it reviewed again, right? Apply it, get somebody, a committer, one of those 22 people to apply the patch over that 9-month period. Then we enter beta testing in May. Okay, we're beta testing from May until August, and then September, October, we will release the final release, which contains all 9 months of these patches. Okay, there's no grand scheme, there's no roadmap of what we're doing. I know that sounds also crazy, but we don't employ anybody, so we can't say, you go work on this thing. But what's amazing to me is because we have people working all over the world, people in Russia see deficiencies in the database that we don't see in the United States. People in China, Japan, Germany, Brazil see deficiencies that we don't see. And what happens is the deficiency only has to show up to one person. And that one person will see the deficiency, they'll write a patch, they'll get it applied, and by the time we need the feature, by the time everyone realizes it's deficient, we already have it. Classic example, PG Vector, we talked about that for AI. It was written a couple of years ago. I heard of it a couple of years ago, it sounded interesting. Oh, okay, you can do vector math, I guess that's cool. Like that's literally the way I thought of it. It's like, all right, we can do vector math, that's nice. I was a math teacher, I know what that is. When AI showed up, generative AI showed up, 2.5 years ago, people are like, well, what are you going to do for AI? We're like, well, I have this extension over here, it does vector stuff, and we're like, oh yeah, sure. And all of a sudden, it becomes one of our hottest extensions, okay? Never was designed, I think, for generative AI, unless the guy was a genius, I don't know. But again, he saw a need, or I don't remember who it was actually. The person who wrote it saw a need for vector operations 5 years ago, okay? Wrote the tool, put it up on GitHub, I think, is where it is posted. And we're like, oh, that's interesting. You know, probably was a math student and thought, a math professor thought vector was useful in a lot of cases. And then all of a sudden semantic search came in, generative AI came in, and we're like, well, we're all ready, right? So again, very interesting because you've got a huge number of people thinking about what's missing. It only takes one person to find to see the failure, to see the deficiency, and address it. And then sometimes it just kind of takes off. And this has happened over and over again with Postgres and JSON, Postgres and full text search, Postgres and the GIS. A lot of these things were kind of just they were just sort of little projects from individuals, and then all of a sudden, boom, the industry realized they needed it, and it was already there. Other questions?
Which has been your
Yes.
which has been your most difficult feature to maintain?
What's been our most difficult feature to maintain? I will tell you the feature we have not implemented, which is very hard to maintain, and that is the replication of DDL to replicas. Because as you can imagine, there's so many ways of manipulating tables. Alter table, owner, add a column, change a column type, and we've been struggling how to replicate that to a replica. We have some commercial vendors who have done it, but they throw a lot of engineering at that to keep that maintained. Because every time you add a new DDL, now you have to, or do the DDL option, you gotta figure that. So that, the actual maintenance of that is so hard that we really resisted it as a community. In terms of maintaining, I can't say that anything is really hard to maintain because we found a way to make it easy. We automate it, or we like throw an error when we detect something's changed. We're pretty picky about stuff. Like I have 3 types of developers. I have bug fix developers. I don't know if this is familiar with everyone else. I have bug fix developers, I have feature developers, and then I've got what I call infrastructure developers. And my infrastructure developers are the ones who basically want to look at the innards of the system and either improve the testing of it or improve the way the tooling integrates or just kind of smooth out the edges. And I didn't really, when I started, understand that. A lot of companies don't even have an infrastructure people because there's no money in it, right? They're often pushing features as fast as they can. They got some bug fixes, got people maybe sort of like in between stuff, can you fix this bug, right? But infrastructure people, typically you don't have those organizations because it's a long-term investment that may or may not pay off. But because we don't pay anybody, hey, they're all the same, whether they're a feature bug, and certain people just love that infrastructure stuff. So I would argue that a lot of our stuff is so easy to maintain because of that. And if you look at the number of forks of Postgres, and I think somebody said there's like, I don't think that's right. I think there's 209 vendors, database vendors, just in China, and I think over half of them probably are Postgres, but that's just China, right? And if I think of the rest of the world, everyone seems to have a fork of Postgres. Supabase is one of them, right? Elastic's another. Cockroach has some code in there. Yugabyte has some code. There's tons of them out there for some Aurora and AlloyDB and Oracle's Postgres, I guess, a fork, and EDB's Advanced Server's a fork, right? So we got tons of them. But the code is so clean that basically if you're doing database, you want to use our code. Like, it's kind of weird. Great question, though. Other questions? Yes?
How do you interface with the proprietary contributors or the people who write proprietary extensions to Postgres?
So how do we interface with the proprietary extensions? We are happy that these people are forking Postgres and creating new versions of it, but we have no interaction with them. I know, for example, there was a case where I believe it was in Postgres 17, we broke timescale. We did something where we changed an internal structure in a minor release, and it broke timescale, and we kind of had to apologize because we shouldn't be changing the internal structure of things in a minor release. We can do it in a major release, but because we did it in a minor release, it was very awkward, and it forced them to put out a new version of timescale to fix because we broke it. And we sort of learned maybe we don't want to do that anymore. So we don't want to antagonize. We don't want to antagonize our people, but at the same time, we're happy with what they're doing. We're happy they're using our code, but we don't actually have a relationship with them. They don't really come to us. I know there was a big criticism when Amazon started years ago when they promoted Postgres RDS, and at that time Amazon didn't have anybody in the community. And I got a lot of complaints, and oh, Amazon strip mining our code and whatever. And I said, listen, Amazon is doing such a service to us by calling their code Postgres RDS, right? And everyone now who's using Amazon databases are seeing Postgres and seeing Amazon promoting our name, okay? Eventually, and this is true of almost universally, what happens is somebody takes our code, they make a version, they think their version is just so amazingly great that they don't need us at all. Okay, I'm sure Amazon exactly thought that, and I'm sure a lot of other people think that too. But what happens is you get down the road, the community keeps improving and getting better and better, faster than they can possibly do it. Again, if Oracle can't do it, nobody's going to be able to do it effectively. So what happens down the road is they start to say, you know, it might help us if we spend a little time with this community guys, because it seems like they're doing some really cool stuff and it would make our job easier if we worked with them more cooperatively. And effectively that's, I think, what has happened. Let me go to the next slide.